Hello, AP Statistics students. This is Mr. Levy, and I want to first and foremost congratulate you for making it through the AP Stats exam. We're just a couple hours out from College Board releasing the questions for the 2026 FRQs, and I'm coming to you with some early solutions. The goal of this video is to cover questions 1 through 3 of the 2026 FRQs for you to go through them and see if your answers align with these answers so you can start to get an early prediction of how you did on the FRQ section of the AP exam. Overwhelmingly, students felt like the multiple choice was very doable this year. The FRQs gave students a lot more trouble, specifically on timing. And so many of my students, at least, mentioned not being able to finish all the way through question 6 or having to skip a couple parts of some questions. So you are not alone if that was your experience, but hopefully this gives you some context. You can compare your solutions and see more or less how you think you did on this section of the exam. If you catch any errors, please let me know in the comments below. I'm recording these videos very quickly after College Board released the questions. I've double checked them. I don't think there's any mistakes that I made, but if you find any potential mistakes, please let me know and I will be very quick to address them. Alrighty, so question 1 of this year's AP exam was a Unit 1 question where we're looking at the weight of goats across 2 different breeds of goats, and we're trying to compare and contrast them. In Part A, we were given a sample of 14 goat weights from one breed, that would be breed H, and we were asked to compute and list the 5-number summary. Now the 5-number summary is the minimum. It's Q1, the first quartile, the median, Q3, and the maximum. And I used my calculator's one variable statistics function in order to do just that. I got a minimum of 48 pounds, a Q1 of 56 pounds, a median of 64 pounds, a Q3 of 72 pounds, and a maximum of 80 pounds. Now for Part B, we were given a box plot that summarizes the weights of goats in the sample of 14 goats from breed J. We weren't given the raw data itself as we were in Part A. We were asked to use the 5-number summary that we came up with in Part A and this box plot to compare both center and variability for the distribution of weight across both samples of goats. And here's my answer. I said the distribution for both breeds seemed to have similar centers, with medians close to 64 pounds for both breeds of goats. The breeds differ in their spread or their variability, with breed J seemingly having more variability than breed H. This can be seen by comparing ranges as well as IQRs for the two distributions. For breed H, the range was lower at 32 pounds compared to about 40 pounds for breed J. Again, I'm reading that by reading the median from the middle of the box plot here in Part B of the question. Then it says the same comparison holds true for the inner quartile range with an IQR of about 16 pounds for breed H and a higher IQR of about 24 pounds for breed J. Finally, in Part C, we are given a stem plot so that we can actually see a graphical representation of the raw data that we were given in Part A for breed H of goats. And we were asked if a box plot were created from the 5-number summary that we created in Part A, what characteristic of the shape of the distribution of weight for this breed, breed H of goats, would be apparent from the stem and leaf plot, but not from the box plot. And I said from the stem and leaf plot, we can see that the distribution of weight for breed H goats is approximately symmetric and bimodal, with a peak in the 50s and a peak in the 70s. A box plot of the weights of breed H goats created from the 5-number summary would not show a complete picture of the shape of the distribution of weights. The bimodal nature of the graph would not be apparent from the box plot, though we can clearly see it here from the stem plot. And they want to know why a box plot would not display that characteristic, in this case, the bimodal nature of the shape of the distribution that we just identified in Part CI. And I said box plots are a very quick and easy way to represent certain features of a distribution, namely the 5-number summary, which makes them very useful when discussing center and spread, but due to their simplicity, they have no way to show certain things like peaks, clusters, or gaps in the underlying data, which makes a trade-off of using them, that certain nuances of the shape of the distribution makes them hidden from viewers. In this case, anything happening between quartiles, like the bimodality of this graph, you cannot see. And that's question 1. On to question 2, which was a description of an experiment. So this is coming from Unit 3 of the course. We're learning about Holly, a botanist, who read an online report that stated that adding coffee grounds to the soil of rose bushes will produce more roses. Holly decides to conduct an experiment to investigate this claim, and she grows 30 rose bushes in a greenhouse with a controlled environment, so the conditions are the same for all rose bushes. When the rose bushes are about a month old, she randomly assigns 15 of them to have a half a cup of coffee grounds added to their soil every week, and the other 15 rose bushes not to have any coffee grounds added to their soil. And after 3 months, she counts the number of roses on each rose bush. We are being asked to identify the treatments, the experimental units, as well as the response variable for Holly's experiment. And in this case, we had 2 treatments, 1/2 cup of coffee grounds added to the soil weekly and no coffee grounds added to the soil weekly. The experimental units were the 30 rose bushes in the greenhouse that Holly grew. And finally, the response variable, the number of roses on each rose bush after 3 months. Part B of this question is asking us how treatments could have been randomly assigned to the experimental units so that each treatment would have received the exact same number of experimental units, in this case 15 and 15. I said assign each rose bush a number from 1 to 30 and create 30 identically sized slips of paper, each with a number corresponding to one of the rose bushes. Place all slips into a large hat and mix thoroughly. One at a time, and without replacement, choose 15 of those slips of paper, mixing thoroughly between each selection. The 15 rose bushes that correspond to the 15 slips that were selected will receive one of the treatments. I went with the coffee ground treatment, but you could have gone with the no coffee ground treatment. The remaining 15 rose bushes will receive the other treatment. So in my case, they will serve as the control group. A lot of my students, I'm sure, will have said you can flip a coin to determine which group receives which treatment. That's totally fine, but not required. In part C, the question says, after the experiment, we wish to determine if the results were statistically significant, or we were told that they are statistically significant, and they want to know what does that mean in the context of this problem. And I said, in the context of this problem, statistically significant means that the rose bushes in the coffee ground group had a number of roses that was higher than the number of roses in the control group by an amount that was large enough to have been very unlikely to have happened by chance alone, under the assumption that the coffee grounds had no effect on the number of roses produced by a rose bush. In this case, because we're talking about a 5% significance level, this would have to have a less than 5% chance of happening by chance alone under that assumption. And this would allow us, and I don't think this will be required by the College Board readers, but I added, this is true, that this would allow us to conclude that we have convincing evidence that the presence of coffee grounds in the soil caused the increase in the number of roses. And now for question 3, the question that it looks like across the internet gave students around the world the most trouble. I'm not sure why it was a probability question. Pretty much all of it came from Unit 4, but let's go through it and see if we can identify what made it so challenging for some students. We're told that a certain sports team has its team song performed by different musicians at the beginning of each of its games, and the time it takes for that team song to be performed by different musicians can be modeled using a normal distribution with a mean of 109 seconds and a standard deviation of 16 seconds. So there's some variability from performer to performer in how long it takes for this song to be sung. I think often at sports games when the national anthem is sung, that some performers seem to sing it so much quicker than others. And so this question, I think, was probably based off of that phenomenon that you can see across many different sports games. All performances of the team song are independent. Now, part A says, what is the probability that a randomly selected performance of the team song will take longer than 120 seconds? And we were asked to show our work, which is something we should do anytime we're getting a numerical answer on this AP exam. And this was just a Unit 1 question, right? The normal distribution is introduced at the end of Unit 1. Again, I am just making sure that the reader knows that I understand that the song length, the time it takes to sing the song, is normally distributed with a mean of 109 seconds and a standard deviation of 16 seconds, which allows me to use normal CDF. And this is my work. My answer is 0.2459, 24.59% chance. Part B, they tell us 10 performances of the team song will be randomly selected, and they want us to introduce a random variable x, a number of games at which the performance of the team song takes longer than 120 seconds. They want us to know what is the probability that that random variable will take on a value that is 3 or more. Now, I want to use the binomial distribution. I should check bins. So B, are the trials binary? Yes. Each time a song is sung, it can either be success, take longer than 120 seconds, or not. Those trials are independent. We are told that the performances of the team song are independent. There is a predetermined number of trials, that is 10. There are 10 times this performance is going to be randomly selected, and they all have the same probability of success, which we found in part A, 0.2459. So you can define the binomial variable having n equal to 10, that's the number of trials, and p, the probability of success, as 0.2459. Thus, the probability that this random variable will take on a value that is more than 3, so again, that's 4 through 10, is 1 minus the probability that it will take 2 or fewer times. And because it is a number or fewer, I can use binomial CDF. My answer was 46.2% chance. And now we're being told about the third random variable y, which represents the number of games Ben will attend until performance of the team song takes longer than 120 seconds. So now there is no predetermined number of trials. He's just going to continue going to the games, and he wants to essentially stop the count for this random variable when he hears the first song that takes longer than 120 seconds. That should scream geometric distribution. And the mean of the geometric distribution, which we're being asked for, can be found by a formula that's on the formula sheet. The mean of the geometric distribution is 1 over p, the probability of success. In my case, I got 1 over 0.2459, which was our answer from part A. I got 4.067 times, or games in this context. Then we're being asked to calculate the standard deviation of that variable y, and to show our work, I got a standard deviation, again, using the formula for the standard deviation of a geometric variable of 3.53 games. We're finally asked to interpret in context what this standard deviation means, and I said in many repetitions of this situation, where Ben continues to go to these games, the number of games that Ben would have to attend until a performance of the team song takes longer than 120 seconds would typically deviate from the mean of 4.067 games by about 3.53 games. Ladies and gentlemen, those are my early solutions to questions 1 through 3 on the FRQ portion of the 2026 AP Stats exam. If you give me about an hour, I will have uploaded solutions to questions 4 through 6 to join these solutions to questions 1 through 3. I hope you have an amazing rest of your day and that you can share this video with your friends, compare solutions, and make sure that you're on track for your target score, whatever it is, on this year's AP exam. See you soon.